basically a developer. I've been writing software professionally since 1998, and I've chosen to specialize in test automation more and more over the years. So this talk is about some of my experiences. I currently work for Pragma, which is a consultancy company, but most of the experiences I'm talking about today were at my previous job when I was employed at a product company. I wrote a book a few years ago about coding dojos and learning test-driven development, and that's probably what I'm best known for. And you can follow me if you want on Twitter. So let me tell you a little bit about Pagero, which is the experiences that I'm speaking about today. So we have a product for financial supply chain networking, which basically means we facilitate the exchange of electronic documents between businesses, mostly invoices. So, for example, a large company would engage our services, and they would say to us, okay, we want to receive all our invoices in this particular format from you so that it goes very smoothly into our whole accounting system. And Pagero would say, yes, of course, we will phone all of your suppliers and contact them and get them set up to send all the invoices to us in whichever format is convenient for them from their accounting software, and we will then transform it into the format that you want it in and deliver it to you. So it's basically a huge cloud-based document transformation service. And this service has proved very popular in the Scandinavian countries, where it's growing strongly. And Pagero, as I speak, is expanding out into Europe and providing this service to more and more countries. So I joined the company in late 2013, and they were just moving to a microservices architecture at that time. So this is an architecture diagram. Now, I don't know if you went to Simon Brown's talk earlier about architecture diagrams. They're not. He says they don't have technology choices on them. Well, I've got loads on mine, I'm afraid. And these may not be technologies you're really familiar with. We were using RabbitMQ for sending messages between microservices written in Scala. And that huge, great microservice in the middle is not a microservice. That's a former monolith written in Java, which we also Dockerized and deployed in the same way as all the other microservices. Originally, we had this huge Postgres database, and more recently, we moved a lot of the data into Cassandra because it's distributed and can handle more data. And the reason that we did this, we started with this great big monolith that had been in production for like 10 years. We needed to scale, so that was the reason for starting to build all the new functionality in microservices to try and handle the volume of transactions we were needing to handle. So I've got a few numbers so you can get an idea about this. When I left, we were about 45 developers, split into 7 teams. And we had about 60 microservices, and that figure is growing all the time. But our monolith, as I said, had been in production for nearly 10 years already, and the whole microservices change was ongoing. It's still being split apart. So there's no numbers on the graph, because that's commercially sensitive information, but you can see that the growth in traffic we were handling was just growing exponentially, basically. And so we needed to do something. Our monolith wasn't handling it. And you can see the regular dips in the graph. That's July. Nobody sends invoices in July in Scandinavia, apparently. So, as I said, we were several teams of developers, and we organized it so that teams were largely responsible for a service or a feature area, or a number of services. But one of the teams was different. That was the one I was in, the infrastructure and architecture team. So our job with this was to provide the infrastructure that the developers in the other teams needed to build features so that they could go and build microservices and get functionality working and provide business value. So we built all the deployment tools. We built all the build pipelines. And we also built, of course, the test infrastructure that they should use. Or we offered them a test infrastructure. This was our service to the developers. we wanted them to build great features and have regression tests for them. So we tried to make it as easy as possible for them to write those regression tests. So this was kind of how we had things set up. We were at the same time as moving to microservices, also trying to deliver more frequently, move to a more continuous delivery setup, because we could see that if you deliver more frequently, you reduce the lead time, the customers get the features sooner, but also smaller batches should imply higher quality. It's easier to see when an error occurs in a smaller batch. So that's what we were trying to achieve. And when I joined the company, the release schedule looked something like this. It was like we were getting a new version out once a month with lots of changes in it. And unfortunately, all too often, the days following the release was a bit of a panic of hot fixes. That's the kind of black and orange stars there. And this happened from time to time, that we did have to emergency hotfix the system. So 3 years later, then we had all these microservices, and they are much easier to deploy, and we were able to put them out much more frequently, so that the release schedule started to look a lot more busy. There were a lot more of these smaller releases going out, and we did actually see a reduction in the number of hotfixes that we needed to do. Hotfixes being a bad emergency release as opposed to a kind of a normal, routine, scheduled release. So the reason we were able to achieve this was obviously partly because of the new architecture, the microservices, but also I like to believe it's also due to the testing strategy that we put in place. So that's what we did. We had fewer hotfixes a few years after introducing better testing practices. So that's kind of an introduction to set the scene of where we were at. And let's look a little more closely about the actual testing part of this. So I've got some theory about testing. Now, the test pyramid is often cited as a good way to think about deciding what kinds of tests to do. Mike Cohn introduced this in like 2009. He was trying to point out that it's good to have a lot of unit tests because they can find some very important issues at a minimal cost, and they are very good for the developers to write to help them verify the code does what it thinks it does. We still need these end-to-end tests at the top of the pyramid for testing the whole functions to make sure that things hang together, and these tests are really valuable because they test from the user perspective. They're looking at how the user would behave in the system, and they will find issues that the users would really care about. So we need some of those, but Mike Cohn was pointing out that if you do all your testing here, that gets very expensive. And you can have more cost-effective testing by pushing the testing down the pyramid. And he points out this layer in the middle, which he just calls service tests. And it's kind of, this is when you haven't got the entire system up and running. But it's more than just a class or a method. And it's a good balance, perhaps, between testing stuff that's relevant to the user while still keeping the costs of those tests lower. So when I came into Pagero, we had a testing pyramid that actually looked fairly good compared to this kind of ideal. I mean, it wasn't perfect. We did have probably more GUI tests than you needed, and we didn't have quite enough unit tests as you would like to have. But still, there were all these layers for the monolith. We had unit tests, and we had GUI tests for the whole thing. In between, we had some data layer tests, because a large part of our system was the object relational mapping layer that was talking to the database. So we had a lot of tests around the integration point there between the database and the layer of objects. Then we had service layer tests, and this is where we have an API to access the application and test a whole feature. So I hope you know this already about unit tests. I'll just recap that unit tests are testing just one small piece of code. If they touch the network or the database or something, then they may still be a useful test, but they're not really a unit test. These are the ones that run really, really fast, and you can run them very frequently. So I've as I mentioned, I wrote this book a few years ago about how to learn test-driven development, more or less, how to learn to write good unit tests. And I still stand by this. I think it's a good thing to learn these skills. And when I came into Pagero, I was all ready to start doing coding dojos, and I did some, and I discovered, though, that actually the developers were already very good, mostly, and they knew how to do this stuff, generally. So this wasn't the focus of what I was doing at Pagero. I looked at the data layer and the service tests, and again, they seemed mostly all right. They were quite slow. They didn't break very often, and the developers were still adding new ones from time to time, but it was a lot of work, actually, particularly these service tests that are testing a whole feature. There was a lot of code in one of those, and it was a lot of code that got copied and pasted to the next test. I don't know if you recognize that. And it was becoming unwieldy. I also found when I started working with these tests that Java RMI, I don't know if you know this technology, but this one is, you have to have exactly the same version of the server code as the client code, or else they can't talk to each other, which makes it very frustrating when I've deployed a newer version and I just want to run the same test. And it doesn't work. So I found these tests frustrating, and they were also very, very slow when you access them from outside the Docker container. Once you get out of process with Java RMI, all the calls go over the network. When you're in process and you're testing in the same like JVM as the code, it optimizes away all the network calls, and suddenly your tests go 10 times faster. But once we Dockerized our monolith, we couldn't do that anymore. So we had some of these tests, but they were a bit clunky. And when we moved to microservices, it wasn't obvious to me that we needed the same kinds of tests there. A lot of our new microservices, maybe they didn't have a database. And you certainly weren't addressing them with Java RMI. We were using different protocols. So these tests were kind of there, but they weren't something I wanted to build on. We had these GUI tests as well for our web application. And this is the login screen. You know, so we had tests with Selenium that would log in and do stuff. And they were as good as far as they went, but there were certain kinds of issues that they would never find. So I like to show this. If you put some dancing ponies on this page, just some developers feeling a bit bored sometime, and they decide it needs jazzing up. None of my tests would find that. And even if they were really determined to put ponies on the front page and they wiggle their nose in a very attractive manner, this kind of test is not going to find that kind of issue. So I was looking at the testing strategy and thinking we needed probably to do something a little different with the new architecture. So this article came out about the same time, and I really regret that I didn't find it at the time, because I do think this is a really comprehensive overview of all the different ways that you could decide to test your microservice. This article by Mounted Fowler with these. So his testing pyramid has even more layers, and he has so many different colors for all the different parts that you can test together, and what kinds of issues you'll find if you write tests around those parts. So this is great. I do recommend you have a look at it if you're doing microservices. So just going back to Pagero, the pyramid on the left is what we had before, and this is what we came up really for the microservices. We decided that the natural next layer of the pyramid above unit tests was to actually just test the microservice. Now, a microservice is independently deployable, so I can deploy it by itself on my machine, and it also has an API that I can use to address it. And that makes it a really useful abstraction for testing, because I can deploy it locally and talk to its API. And that is a way for me to test it, kind of black box. But I still thought we needed the GUI tests for the whole shebang. That was still useful to have. And system tests, where you try and avoid those costs associated with using the user interface. And that's what I'm going to talk about quite a lot more, the end-to-end system tests. But it is worth mentioning that we had Microservice Tests too. As I said, you basically deploy the service on your local machine, and possibly if it has a database, you could deploy that too. I would also probably deploy some essential services that the microservice needed, like all our services are using a lookup service for getting configuration, and it's like a read-only database. And they're also using a queue service, a RabbitMQ, to talk to the other services. So we would deploy some of those. But basically, you're trying to test the microservice by itself. You trigger the public API of it, try and get it to do something, and then the test has to then respond to any messages it tries to send to other services. So you have to kind of capture the calls it makes to the collaborator and return something that the test wants to test with. So there's a fair amount of code in one of these microservice tests, and but they did find useful issues just for one service. And if I did this again, I would probably be looking at if we could avoid some of the overhead of these tests, because it does slow them down to be running the tests over the network, talking to the microservice through the queue. It does make it more realistic, but maybe it doesn't actually give you very much more security, and it costs time. So we had these tests, and I think this is useful. But as I said, I've got a whole load of ideas now about how we could test these things better. But I also want to talk more about the system tests that we did. So let's move on a little bit. I mentioned already we were trying to do continuous delivery. So we were setting up a delivery pipeline. And you start at the left side with the programmers working on new features, writing unit tests. Maybe they're doing pair programming, maybe they're doing some other form of review. But anyway, the code comes into version control, and that's where our automated deployment pipeline picks it up, makes sure that the unit tests are all passing, test all the smallest bits. And then if they all pass, maybe we'll test the microservice by itself. And then if the microservice by itself works, then we'll deploy it with the other services and test it end to end. If everything still looks good, then maybe we'll devote some actual people time to this, get some manual testing done in the staging environment. And then if we still feel confident, then we can push it out into production and monitor what happens when we do that. So all the way down the pipeline, we're moving the code into a more and more production-like environment. We're devoting more and more hardware to the testing. We're testing larger pieces of code together and seeing if they integrate. And the test costs increase. And that's not just because they take longer to run and they take more hardware. Of course, that is a factor, that is a cost. But really, the major cost of these other tests is the maintenance cost. When you have a bigger piece of code being tested, it's more likely that you'll get issues with latency problems, or the database is slow, or something happens not quite in the way you expected, and the test fails for no good reason. And then somebody has to go and look and work out, is this failure because something important happened, or is this just a flaky test? And that's you spend a lot of time writing these tests and maintaining them, the bigger they get. So that's really why the whole testing pyramid thing is saying, look, invest in unit tests. These are the cheapest tests that you have. But they don't find all the issues, so you do have to have the other ones as well. You can just have less of them. So let's talk a little more about these end-to-end tests which aren't using the user interface. This is where I put a lot of focus. And this is because, well, when you start looking at your architecture, as I put it up before, and you start to say, well, okay, now we need to have a test case in this architecture that's going to trigger things happening and work out what should happen and assert that it did happen. And this is where it starts getting really complicated. Your test has got so many moving parts to worry about, and it's got so much going on. And this is, I find this kind of problem fascinating. So I put quite a lot of time into this, and I wanted to tell you about what we came up with, basically. So the end-to-end test strategy that we came up with was, well, we don't want to have too many of these tests because they are expensive. Let's just have the crucial workflows, the really important use cases. Let's try and use an API. The GUI just adds another layer of complexity and cost. Let's have an API to trigger the workflows we need to test. And then I found these 3 techniques useful: data-driven testing, approval testing, and event monitoring. So I'm going to say some more about that. But the basic thing is, all of this test strategy is I want to find the important bugs but at the same time keep the costs of these tests as low as possible. The costs in terms of my time to write them and maintain them. And not just my time, but all the developers. I'm providing this test framework approach to the developers who are developing features. And if it's too costly and too slow, they just won't bother. So I have to do something that the developers in my organization are going to want to use because it helps them. So just another note on the thing with why I'm wanting to avoid the user interface. You can test the whole system through the user interface, and that is usually the way the user would go in, and you would see the same bugs as the user if you use the user interface. But the user interface is not designed for a machine, and an automated test is a machine. And you have all these timing issues and threading, and the buttons move, and the test fails, and you just add a whole new layer there. An API is generally more reliable, particularly if it's already a public API. So our cloud system does have a public API. It's a REST API, and a lot of our customers use it to send their documents to Pagero Online. So this was a great starting point for the tests. So we started by saying, well, let's just use the public API. And that worked for about 3 minutes until we realized that actually there's a lot of stuff we want to do that we don't want to let our users do. So we don't want to expose a very wide public API. So we built an additional REST API just for the tests to use that kind of was built on top of the existing public API, but added a load more functionality that we wouldn't want to expose externally. So we built it in a kind of a separate, it wasn't actually a separate microservice, but it was separated enough that we could just not deploy it when we deployed to production, which meant we couldn't run the same tests in production as we could in staging, but that was a price we were prepared to pay for the security, that knowing that no one could get at it because it wasn't there in production. So that's. So I should also mention the main reason we needed this API actually was to create new entities in the system. So in order to send an invoice through our system, you need to have an account. So the test would create an account as the first thing it did. And it would create a unique account just for that run of the test. So you'd create a user and you'd name it user123. And the next time you ran the test, it would create the same user with all the same attributes, but it would be called user456. So you'd know that all the data one test run was working with was unique just for that test. And then you could run them in parallel, and you could wipe the database and run them again, or not wipe the database and just run them again, and it was all fine. It would set up everything for that whole scenario. So then we found that we were really doing data-driven testing here. So the main use case of this system is sending a document from an issuer to a recipient. That workflow stays the same, and you can test a lot of the features in the system just by varying the way you set up that issue and that recipient and that document. So that's test data. So we had that defined in text files. So we had our own JSON format for defining the properties of an issuer for this test case. And in another test case, you'd have a similar JSON document, only with slightly different property sets. And then you could run the test and see what happened. So the observant among you will realize that this is only 2 parts of a test case. It's you're setting up the scenario, you're running the scenario, and then you have to check the result. So the thing with data-driven testing is that you can define a whole new test case just in terms of new data. You don't necessarily need to write any new code if you already have the workflow set up. But if you then have to make some assertions about what happened, then you're back on writing code that's different for every test case. And really what we want to make assertions about, just in this particular use case, is, well, what was it that the recipient received? Did they get the right document in the right format? So data-driven testing is only the first two parts of the test. You needed a way to do assertion. And the classic way is, as I said, you write code to assert things about the output. Another way to do it would be using property-based testing, where you define invariants, that the document must always be contain the name of the recipient. The document must always have one of these formats. These things that you can say are universal for all of the test cases, that there must be a document for a start. So you could do that, but then the kind of generic property-based test that you could write for all test cases is, they start to get kind of complex when you start looking at, well, for this particular test case, these invariants don't apply. Anyway, we didn't do property-based testing, although it would have been an option. What we ended up doing was approval testing. Now, approval testing is saying that instead of having to define a bunch of assertions, what I do is that when I'm designing the test case, I take a look at the output. I take a look at the recipient presentation, and I examine it carefully and determine if it's correct. And if I deem it to be correct, I might need to check with some business person who knows these things. But if I deem it correct, I approve it. And then the next time I run the test, at a conceptual level, I just do a diff. I diff it against the approved version. And if it's the same, then the test passes. And if it's not the same, then there might be a problem. And that's where it starts getting interesting. So I mentioned that often the recipient presentation could be a PDF file. It's equally likely actually to be some form of XML. But in all these cases, I want to do some kind of transformation on it to make it into a standardized plain text format. And there are utilities for converting PDFs to text. We used a Python tool, but there are others. If it was an XML file, then I would use a kind of a lint tool to just lay it out beautifully with all the tags indented at the right level. And then when you've got it in this beautiful plain text format, then you might do a bit of filtering. I'll come more to that. And then you just do a diff, a plain text diff. And you make sure that it matches. And if it matches, the test passes. If it doesn't match, then this is where you want to be alerted to that. So you've got the approved output on the left, and you are looking at the new output that has come out. And the observant among you will notice that those ponies that I was so worried about have crept in here. And we can clearly see from the diff that we have an extra line here. The test has failed. We have ponies that weren't expected. And if we were doing assertion-based testing, I would have been picking out some things to assert in this document. I probably would have picked out the bank account number, the right person's going to get the money. I'd probably pick out to check the amount payable is correct, things like that. But an assertion-based test would very unlikely to have assert no extra line items. So it might do, but yeah. But with the approval test, I'm seeing that kind of thing immediately. So this could be a bug, and I've now found it with a test, or the other scenario is it could be a feature. And that means this is actually intentional. Our customers have requested a new feature that they want us to add this to the invoices. So, okay, in reality, we probably wouldn't be adding ponies, but it is one of the features of this system that it will add stuff to the invoice on behalf of the recipient. So what we want to do at this point then is update the approved output with the new version. And so we want to do this replacing and update our test suite. And this, you could do this by hand. It's just a question of copying a file into the test suite and committing it to your version control system. But it actually really helps to have tool support. And this brings me to Text Test, which is the tool that I've been using for this, that I'm one of the developers of the tool. And this is a tool that's explicitly designed for approval testing and makes this kind of copying files around really easy. So it's a open source tool for approval testing, and it works very well with data-driven testing. It's not the only tool in this space. I would also recommend these approvals tools, which actually were designed for .NET, I think, from the beginning, so they would definitely be worth a look if you're in that space. And then there's this really quite recent tool that just came out called Jest, which is for testing JavaScript. And this tool, I haven't actually used it. I just read their marketing materials, and I'm like, oh, this is doing approval testing. Except they're calling it snapshot testing. So that's fine, okay. Facebook, who invented this tool, decided that it was called snapshot testing. So maybe in a few years I'll have to change my language and call this like that. We'll see. But I think it's the same idea. You're basically doing a diff against a version that you've previously approved. So I mentioned before that you have to lay out the version, you have to convert it to plain text. Actually, you don't. Some of the versions of this tool will work with images. Text test, you can probably tell from the name, it works best with text files. So one thing you can do with a text file is you can do filtering. So one of the things on an invoice, you might display the current date. Of course, the due date of the invoice shouldn't change, but the date that you printed it, that might change. And that's going to change every time you run the tests. And you don't want the test to fail every time the date changes, because that's uninteresting. So with text test, it allows you to define a regular expression to filter out something like that. So this is a regular expression for that date, and it will replace it with a fixed string date. So the document ends up looking like it does on the right when you've done the filtering. And then, of course, the diff works every time, because you do the same filtering on the approved document as you do on the test document. But you'll also notice that regular expression will only match a date if it has the right format. So it will, of course, help you to find, if there is a bug introduced that means the dates don't get printed at all, this will find it. But yes, it will find it because it's replacing it with a fixed string in the approved version. And it will notice it's gone in the new version. But if the date it has the right format but the wrong contents, then I'm afraid this test won't catch that. So it's not a panacea. It will only catch certain kinds of issues. So you do have to be a little bit careful about filtering, because you can, of course, filter out too much and end up comparing documents that are essentially empty because you filtered out everything in them. I've done that. So you have to be careful with your regexes. But if you compare with a case when you were doing assertion, in the assertion case, you're kind of picking out things that you want to check. Whereas in the filtering case, you're picking out things that you want to filter, and the rest is going to be checked. So it's kind of, your role is kind of reversed as a test designer. Instead of picking out what you want to check, you have to pick out what you don't want to check. And that means you catch everything else. And this has some consequences. It has some good consequences in that you spot those unexpected issues, like that. Why did that developer just add that pony there? I didn't expect that, but it's appeared, and now my test fails and shows it to me. So that's good. But it does also mean that your tests are not isolated. You get related failures. So let me explain what I mean by related failures. So if you're familiar with a unit test, you really try and test just one piece of functionality at a time. So when that piece of functionality stops working, one test fails in the ideal case, and you have only one assertion in that test case, and that's absolutely pinpointing the piece of code that it's now gone wrong. And you know that the majority of your system is working, but that one piece of functionality is broken because you have one failing test. That's kind of an extreme. It doesn't always happen like that, even with unit tests, but that's kind of what you're after. When you're looking at an approval test, that very rarely happens that you just get one test failing. Most of the time you get a lot of tests failing at the same time because they are related. You're testing a whole use case. You've got a large piece of code being exercised, and effectively that diff that you're doing is like having one assert on every line of that file. You've got multiple asserts in your test case, and there are multiple asserts that are shared because tests have similar documents. So I've got an example here. We've got 2 different test cases, and these are the 2 approved documents for those tests. And you can see they're not identical. There are differences in the invoice, and they represent the differences that we want to be there because we're exercising different scenarios. But if we think of a new feature that's added to the system that's cross-cutting and changes a large number of invoices, so for example, if we start printing the address differently, we start printing the country on the invoice, as well as the rest of the address. And this might mean that all our tests suddenly fail because they've all added an extra line for the country. And this can be a little bit, you can get a bit worried by this when you run 50 tests and all 50 fail, or even 49 of them fail, and you're like, oh my goodness, what do I do now? But then you start to look at it and realize, actually, all of these are the same issue. I just want to approve this because that's what I intended. And this is where tool support, again, becomes really important with approval testing. You need to have a tool that will help you to identify these related failures. And this is a screenshot of text test. So if you look on the left, I've got a list of 4 test cases. I thought I wouldn't do 50. I wouldn't scare you with that. And the top 3 have failed, and the 4th one has passed. And on the right-hand side, you can see the summary. We ran 4 tests. 3 of them failed, and 1 succeeded. But you'll notice that the top 2 test cases are highlighted, and so is the line on the right highlighted saying Group 1. That's saying that I've grouped these failures together, in that the tool has noticed that they have exactly the same diff. They have the same failure, and all you need to do then is to just look at one of them and make a judgment about whether that is a bug or whether it's a feature. And if you judge it's a feature, you can just approve the whole group because you know they're all the same. And then that 3rd failure that was different, you maybe need to go and look at that because it had a different diff. So what I'm saying is that the tool helps you to spot the related failures. And then, like I said, you then apply the same fix to all the tests in the same group. So either you bulk approve them all, or you decide, well, no, actually, I need to filter that. I'm going to write a new regex, which I'm going to apply to all of those tests to filter that thing out so that the tests pass again. Or maybe you'll identify that actually they're all suffering from the same bug, and you just write one bug report. So this, as I'm trying to point out, approval test has different trade-offs than other kinds of tests, and tool support, I think, is crucial. So this is the big picture then of what a test comprises in this system. We've got some specifications of data saying that we've got these actors, this document, we've got this workflow, we're going to store the actual presentation for reference, but actually what we're going to assert on, we're going to approve the textual representation of that output, and that will determine if the test passed or not. And the whole idea of this is that we want to minimize the amount of work it is to create a new test. Hopefully it's a case of identifying new data that triggers the feature we want to test, looking at the output, approving it, and then checking in a bunch of files into our test suite. When the tests fail, we've got tool support to help us to identify those related failures and maintain those tests. And we want to maximize the potential for finding those bugs we didn't anticipate. We're going to find those things that appear in the output that no one really expected. So this is good, and this was working pretty well for us, in my humble opinion. But there's another thing here. What do you do when the test fails? And there's a bug, and the presentation that you get out doesn't look right. Where do you find where in your whole system the thing broke? This is one of the advantages of unit tests. They absolutely can pinpoint your failure. But this is saying, well, somewhere in this whole thing with loads of microservices, something went wrong, and the wrong answer came out. So we want to be able to at least find, well, whereabouts did things go wrong here? Was there a service that didn't respond correctly, or what happened? And this is where the test case can can actually give you some insights just by listening to the traffic. I mentioned this microservices architecture, and all the microservices are talking to one another over a message queue. So they're constantly like publishing events that they say, this happened to the document. Or they're saying, please do this to the document for me. This is its ID. So you have the test case listen to the traffic concerning the entities that it's responsible for. So I mentioned already that when you create a new recipient or issuer in this system, I give it a unique ID just for that test run, which means that the test will just listen to all the messages on the queue, but it knows the ID of the entities that it created, and it will just write to a file all the events that concern those entities. So you end up with a log that looks something like this, with these are the events that happened, this is the messages that were sent regarding this document. And this can really help you to debug what happened. When the test fails, you can compare the approved version of the event log against the actual event log that you got from your particular test run. And this gives you some insight into what happened. Quite often, an event is missing or an event is malformed and some service doesn't pick it up the way they should. So this actually gives you some clues about what went wrong and where to start looking for the problem. So we store this in the test as well. The test case basically comprises a folder with lots of files in it and a link to what code to run for the test workflow. So this is what we are storing in our test case. And version controlling in version control system. So that's kind of like the static view of one test case. I've talked a lot about that. Let's talk a little bit more about how we ran these, how we arranged them in our delivery pipeline. So as I mentioned before, we were doing multi-team development, and a team would be responsible for one or more services. And that meant that when you look at the delivery pipeline, this is this picture I showed you earlier. In the system test, you have several services deployed, and those services are kind of owned by different teams. So that has means that actually this is too simplistic. The delivery pipeline looks more like this. You have a team that will be working on their services and running their unit tests in their bit of the pipeline, and run the tests for their microservice, and then they will deliver to some kind of shared pipeline where we're going to do system test. And this point where the streams meet, Team A and Team B suddenly start to have to care about each other's work. Up until that point, they are working in kind of isolation, testing their small pieces of code that they are responsible for. But system test is where it all starts getting interesting. And this is where we ran into some difficulties when we first set this up. Having come from a monolith, where you run the system tests for your monolith, we didn't quite set this up the right way at first, I think. So we set up our build system in Go CD, which at the time had a much more sophisticated way to handle pipelines than other tools that are available. I'm sure there are other tools that can do that, the same thing these days. At the time, this seemed to be the best choice. But the pipeline structure looked like this. You'd kind of build the services, and then you would update a bill of materials that lists, this is what the file is, basically a text file that just lists all the services and which is the latest version of them, which is the most recent version that was built. And that's the versions that we're going to then send to system test. And system test is going to run all the tests, and when they pass, it will deploy it to the staging environment for manual test. So there's a problem here. It's that little thing, when all your system tests pass. Because our experience was that they didn't pass. Somebody would make a mistake in their service, and some test would fail, and it would just be difficult because something would always be failing. And so the first thing we did was split apart that one suite of system tests. We needed to do this anyway because they were getting too many of them to run at once. So we split them up and run in parallel on different build agents. And have one of the suites focusing on one feature, and the other suite focusing on another feature. And actually, we had more than 2 of these, just like we had more than 3 services. This is kind of a simplification. So this was an improvement. We're getting faster feedback because the tests are running in parallel, and we get a result sooner. And we also found that we didn't maybe need to deploy everything. If we were just testing feature A, it might not need all the services, so we saved compute power as well. But it still happened that people would break the tests, and it would still happen that we couldn't get stuff out into staging. And that becomes more obvious if I just highlight the areas that each team owns. So team A owns these 2 services here and this feature, and team B owns this other service and this other feature. And so say team B makes some mistake in their service that they don't catch, and when it gets to the feature B tests, it all fails. And that's really team B's problem to solve. But it unfortunately means that team A can't get their stuff out into staging because we want all the tests to pass before we deploy to staging. And so we built tooling, we built dashboards that would show team B, you are causing a problem. This kind of make it visible, and then the problem will go away. But unfortunately, it didn't. People would just say, oh, yeah, I'm fixing that. And it would still slow down the other teams. So we realized that we were thinking about this wrong. We needed to make sure that our teams were not just building independently deployable services, but they were testing them independently so that they could go further, go potentially all the way to production without being impacted by another team messing up. So we rejigged our pipeline structure to extend the period where a team could work independently of the other teams, basically. So I've shortened bill of materials to BOM there. But if you remember, that's just the list of all the versions of the services that you want to test together. So what we did then was have a kind of a feedback loop so that when team A wants to test a new version of their service, they grab the bill of materials of what's currently passing, the known good versions of everything, and we'll take that and we'll just put my new version of my service into that bill of materials, and then I'll run the tests. And this is before anyone else has seen the new version of my service. And so if it fails, it's only my team that has a problem. Of course, if the tests pass, then I say, great, I'm going to send this in to the overall whole bill of materials for manual testing and staging. And that means that they can get their stuff out. And if Team B has made some mistake and their feature tests are failing, they don't get blocked by them. But of course, if you're observant, you'll realize here that if Team A is missing some test cases and they break Team B's stuff without realizing, then of course they will still block Team B. But it's hopefully a little bit less likely because at least their own tests passed. And if you're breaking stuff for another team without realizing it, that means that you're missing a test in your suite. And hopefully you can talk to that other team and write that test case. And next time you'll find it before the other team gets affected. The other thing, we realized also you might not have run all the tests against all the latest versions of everything. So you might need to run the tests again before you deploy to staging, which we set that up, but I'm not sure it was needed. I don't think those fail very often. So this is kind of a work in progress. I'm kind of showing you where we got to with our pipeline structure, and hopefully it's helpful. I've got some more later about where I think this is going, but this is about where we got to. So that was one plank of our testing strategy. We had these end-to-end tests for new features that we were writing with synthetic data. The test created its own data. So that was very good, but of course, when you get into production, the data might not look quite the same as your data that you've designed for your test cases. So this wasn't the only kind of testing we did for the whole system. So if you think about testing and staging versus testing in production. This testing and staging is kind of safe in that sense. If you deployed something that really doesn't work, none of your users can see it, so it's fine. And you can try anything out you like, you can unplug cables, and really it's not going to bring your whole production environment down. And so this is why a lot of people use staging, because it's safer. The trouble with staging is that it's got less hardware than production and less data, which means that some issues that you see in production just never arise in staging. And that's bad enough, but even worse is that when you find issues in staging that you discover never occur in production. So you find you've been chasing this bug, and actually it's in production you have more hardware and it just never happens. So this is kind of thing where actually maybe this shouldn't be your only part of your end-to-end testing strategy, is to only test in a staging environment with synthetic data. So one of the things we were also doing was difference testing, where we would take our production system that was running production code and doing stuff, and then we would deploy into it a new version of one of the services with some a kind of a sandboxed area of production where it couldn't talk to anything else, it couldn't affect anything. And then we would, so that's called a dark deploy, where it's there but nobody can see it. And then you start directing a duplicate of some of the production traffic to it. So your new version starts to see some of the traffic and can work out what it would do with it. And then instead of then sending that response to somewhere where anyone could see it, like a user or it just logs it, basically, and probably compares it with the value that the production version of the service is returning. And then you can see what happens and whether your new service is behaving mostly the same as the old service. So we were doing this, and we were mostly doing this by hand, actually, just having it log and then leaving it there for a few hours and then looking at the logs and see what it did. And this was good. We found issues like this. This gave us a lot more confidence that our service would handle real data. And there's this tool called Diffie that we never tried, but I think it would be something I would try now if I had the opportunity, which basically automates that checking, did it do the same thing as the production version, what were the differences? So that might be worth looking at. The other thing we did was regression testing, bulk regression testing. So we would take a portion of the production data into staging. Obviously, the production database is enormous, and we can't duplicate the hardware in staging to handle that much data. But we can take a portion of it to test with, and then we can rerun thousands of documents and just compare. And I've got the manual testing little thing here because I tried to automate this. I tried quite hard to automate this so that we could put it in our pipeline, but production data is too messy. I found there were always differences and always needed to look at it and make a judgment about whether this was okay. But maybe in future I would find some kind of way of doing that diff and making it more automated. So that's kind of what we did do. And now I'm going to speculate a little about what we should have done some more of. Here, this is what our team pipelines ended up looking like. But as I said, we still had this staging. We would still test things in staging before we went to production. And I've spoken to people with a much bigger microservices setup than we had, and many more developers. And they're like, this doesn't scale. If you only have one staging environment that everyone has to go through, it doesn't scale. So at some point, we may have experienced this. So what a lot of people do then is basically keep the pipelines for the different teams entirely separate all the way to production, so they don't affect one another, and they don't have this bottleneck of staging. And then you have techniques like incremental rollout, so that you can reduce the risk of deploying versions of the services that have never been deployed together before. Because you've never deployed them previously in staging together. You can roll out your new versions and reduce the risk by only showing it to a certain small proportion of your users until you're fairly confident that by monitoring it, everything's okay and you can roll it out to everyone. So this is kind of where I think we would have probably be going in a few years when the size of our microservices architecture is bigger and our development teams are bigger. So that's kind of where I think it's going. We didn't get there. So just to summarize, this is my last slide. I'm just going to go through some of the ideas that I've presented. So the testing pyramid, I think, is a good metaphor to help you think about the proportions of the different kinds of tests you might need and how to optimize that so that you get the best return on investment. So you're not paying too much for your maintenance costs, but you're still finding useful issues. I think it's useful to think about the how you make a deployment pipeline and what tests you put at each stage of that pipeline. And it's for me, the end-to-end automated tests are that's the hardest ones to get right, the ones that can potentially cost you the most. So that's where I've put my focus. I've introduced techniques like data-driven testing and approval testing, and I'm using this tool text test, which there are alternatives, it's just the one I used. Approval testing as a technique is entirely platform independent, but I think it's good to have a tool that will help you with related failures and help you with filtering and help you to update approved versions. I don't think you should just roll your own. I think you should find a tool. And then just at the end there, I was talking more about the keeping teams owning different microservices independent of one another and keeping the tests independent of one another as well, so that failing tests that one team owns don't stop another team necessarily from deploying their things. So thank you very much. That's what I came to say today.